in brightest day, in blackest night, no evil shall escape my sight. Let those who worship evil's might beware my power. Green Lantern's light. In brightest day, in blackest night, no evil shall escape my sight. Let those who worship evil's might beware my power. Green Lantern's light.
all to Saturday Evening Talk. We would be starting our lecture within 3 minutes at 7:35 exactly. Very good evening, everyone. Sorry for the inconvenience. It gives me immense pleasure to welcome you all to another insightful Saturday evening talk where knowledge, innovation, and practical experience come together. Today, we are honored to have us with Nachiket Shah, a dynamic professional with experience across BIM, architecture, technology, education, and leadership. His professional journey includes Chief Executive Officer at Roshani Technologies Pvt Limited, founder of Roshani Design Studio, BIM Consultant, and aspiring architect, ex co-conveyor at Indigenous, director at JCI Baroda Alkapuri. He has also taught more than 20,000 students. Additionally, he also has been a faculty at L&T, Linde, Sardar Sarovar Nigam Limited, and many more industry professional. I would like to acknowledge the prestigious organization who have extended the support. Indian Institution, Indian Institute of Architects, Institution of Engineers, Computer Society of India, HR Milestone, JCI Baroda Alkapuri, Baroda IT Association, Baroda Productivity Council, Vadodara Innovation Council, ISTD. Today, He, he is here to share his knowledge and perspective on the fascinating topic application of parametric architecture in the design of sustainable mixed use commercial and residential building, a topic that brings together architecture, technology, computational design, and sustainability, four important elements shaping the future of the built environment. I am sure today's session will give us the valuable insights into parametric design can be used to create smarter, more efficient, and sustainable architecture solutions. So, without further delay, let us warmly welcome our speaker of Saturday Evening Talk, Mr. Nachiket Shah. Over to you, Nachiket Shah.
Thank you so much, Vishwa, for giving a wonderful and a mind-blowing introduction about me. I'm very glad. Thank you so much. Yeah, today's topic is one of the most important topic where all the architects across the globe are talking about. So it's a parametric architecture, wherein also what we have done is that we have incubated a parametric architecture with the sustainability. So the sustainability is one of the most key element now. Each and every, whether a real estate developer is being concerned, as an architect is being concerned, as an structural engineer is being concerned, all are talking about the same. So let's not waste the time and let's on boom with the topic ASAP. So now before starting on with the session or before moving ahead, uh, I would like to raise a question wherein would you like to do a hard work or a smart work? What would be fascinated to you? Whether it would be hard work or smart work? Can anyone write in the chat box? Yeah, I guess we have certain answers that is smart work. Yeah, and why smart work? Because smart work is something. Thank you, Parag Pandya. You want to be a smart like you. Thank you so much. So we have two different opinions when some people are saying that hard work and some people are saying smart work. But if you say my opinion would be considered as being a
Recording
smart.
in progress.
Be a smart work is just because ki smart work is something wherein we don't do. In Gujarati we say that ki gadeda jevu kam we don't want to do. Is something that we do something with putting our mind inside and doing something. So today's topic is something very relatable to how a smart work is being functioning in the, let's say, the future of architecture, future of construction, and as far as the AEC segment is being concerned. So now the today's topic is one of the most insightful topic, and I don't know whether the people uh, in the same segment are talking about. Yeah, they would be talking about parametric architecture, and they would be talking about the sustainability in architecture, but they would be talking the same as two different topics. They won't be talking about parametric architecture along with the sustainability, wherein we can fetch the majority of the sustainable construction through parametric architecture is what this presentation is all about. And again, we would be, and my topic is not only limited to the use of the commercial, but it is also being at the same the use of the residential building as well. Now, I would be asking a certain question. What if a building could design itself based on the sunlight, wind, energy, and a human comfort? So I guess everybody would be curious. Okay, TK, this would save my time. Okay, so now this is what actually a power of a parametric architecture is all about. Now, I have said a plenty number of times parametric architecture, parametric architecture. But now, what exactly the parametric architecture is all about? What actually the function of a parametric architecture is all about? How does a parametric architecture basically functions over the scene? So, my first point over what a parametric architecture is all about is the modern approach. So now one of the most modern approach is the parametric architecture. So we can say that it is basically a computational method of creating or articulating the architectural designs or constructing the computational model of an architectural design is what a parametric architecture is all about. But it is not only limited to just the modern approach. It is much more than what we are seeing in the slide. Parametric architecture is something wherein the design is being basically being controlled with the factors like size, shape of an element, the height of the element, not only the physical factors, but the, let's say, the environmental factors, which are the major concerns in affecting the, let's say, high rise buildings or the large commercials, and a good dynamic buildings, that is the sunlight, the wind, and the materials. So these are basically, it uses the parameters, and the word itself says that the parametric. So the use of the parameters to function or to optimize my design is what a parametric architecture is all about. Second, what parametric architecture basically uses. So parametric architecture is basically, it uses the rules and the algorithms. Now, what is the rules and algorithms? For example, the rules and algorithms in a way like from the southern side, if my temperature, due to the sunlight, the interior temperature becomes 36 degree. So my model or my, let's say, the facade should be in such a manner that it should block the sunlight. So the interior temperature uh, should be sufficient enough or should be comfortable. So that is what a rules and algorithms is all about. So a step by step series of the, let's say, the orders which we basically give to the, let's say, the model or the trained model that we develop is what a parametric architecture is all about. And this is the one of the most key element wherein we generate our own rules, we generate our own algorithm to create or rather to optimize or rather to automize the design is what the power and the function of the parametric architecture is all about. Quite fine designs, right? wonderful, brilliant designs, right? So this could be easily been done with the help of the parametric architecture, where changing of the one parameter can change the all the other elements, wherein you can easily see in the, let's say, the fourth image, you see the circles. Okay, so the dimensions of each and every circles are not the similar, and the glass facade which is inside the circle is also not the same in each and every, let's say, it's not circle but it's an elliptical or it's an oval shape, oval kind of shape. So it's all the circles or all the shapes are not even similar, right? So they are basically an irregular shapes. So what do you think? Each and every shape or each and every circle or an optical, let's say, the facade has been created by an individual singly. किसी ने ये एक एक सर्कल को खुद से बनाया होगा? No, right? It has been already been automized, wherein it has been given a function wherein the circle should be in the, let's say, for an example, it should be an inclusive format with respect to x plus 2 or with respect to y plus 2. So this is the rule or an algorithm which we have given to the facade or while designing the facade of the same. So this is what a parametric architecture is all about. Yes, sir. This parametric I mean, Kumar, sir, the parametric architecture is quite being in trend in Dubai, and now also in India. If you see a uh, certain luxurious places or the convention centers, all are being made with the parametric architecture. You see the airports, you see the airport of the Mumbai, it is completely a parametric architecture. Even the convention center in, let's say, Mumbai, which is for Nita Ambani Convention Center, it is one of the most and the best example of the parametric architecture in India. Thank you so much, sir. So where if I change just a small parameter, for example, if I change from x plus 2 to x plus 4, so I can see and I can reflect the same in my design. So this is what a parametric architecture is all about. It helps me in saving a lot of time, wherein I can automate each and everything rather than doing, let's say, rather than designing each and every shape, each and every element just to suffice my work. Again, it helps in creating a complex forms, fluid geometries, aerodynamic shapes. It could be easily being served with the help of the parametric architecture. So this is what a parametric architecture can do basically. Now this is one of the most key important thing wherein a parametric architecture can respond to the environment. Design can adapt the sunlight, climate, wind, views and the site conditions. For example, if the wind is coming from northwest region towards the, let's say I'm creating a skyscraper, the flows would be exceeding 57 flow. It would be exceeding more than 57 flows. So you can assume the wind speed at the 57 at the 57th flow. It would be much more. So a much more structural conditions would be apply over there, or the structural precautions should be provided in that particular case. But with the help of the parametric architecture, we can give the aerodynamic shape due to which the winds can easily pass through without affecting the structure. So this is what a parametric architecture can all about. And at the same point of time, for example, there's one building in Dubai. Uh, I'll just quickly show you that building and then we can come back to that. So it is known as the Al Bahar Towers. So this towers is basically being made in such a manner wherein it can collect the sunlight or it can invite the sunlight from inside the building. So this is this is a live example which is in front of us, that they have started using the parametric architecture just to suffice their needs. So this is how it responds to the environmental conditions. And it is not just only the sunlight and the wind. It can be can be the seismic waves. It can be the, let's say, the topography. It can be the contours of the lands. It could be anything, wherein it can be also being as the site location. For example, if I don't want to cut down the trees over on my site. Rather, I want to preserve each and every tree which is available on my site. So, in that particular case, I can give a relation. I can curate a relationship in such a manner wherein wherein the trees on my site would respond with my building. So I can say that if there is a tree which has been coming in the path of my building, so there should be a slice or a cut down in my built environment just to keep that tree alive. So this is a very small example wherein what a parametric architecture can easily do without any, let's say, hard work, or let's say we can say that कि गधे वाला काम किए बिना किस तरीके से हम उससे we can make our work being done easily. Second, this is basically the seven iconic parametric architectures. That is one of the most attractive is Al Bahar Towers. It is currently in Abu Dhabi. It was being created by the ADAS architectural firm. Then we have the Haider Alif Center. It was being created by Zaha Hadid. Then we have again the Opus. Again, it was being curated by Zaha Hadid. It was again in Dubai. We have Ko Bojan 2. It was being designed by Ingen Hoven Architects. Again, we have a Metropole Parasol. It is currently located in this Spain. And we have J. Mayer H. Architects Consultancy as the main architect in the same. Beijing Dexing International Airport is one of the most and quite a good example of a parametric architecture being used in the airports. And parametric architecture, what I believe is something, it's a beautiful use of the space. For example, if I want to use the optimum use of the space, so I can easily do it with the help of the parametric architecture. I hope my voice is audible. Can anyone give the confirmation in the chat box? Yeah, thank you so much, Amit Kumar, sir. So we have again there are two header alive. There we have cultural center and we have justice convention center. Again, been developed by Zaha Hadid. Zaha Hadid is to be known as the let's say the pioneer in creating the parametric architecture. Again, we have Franco Gehry sir as well as the, let's say, the father of the parametric architecture. So now, what are the basic principles and the applications of the parametric architecture? So the basic principles and the applications where it is being used in the parametric architecture is something. Yeah, sorry for the glitch, guys. We already talked about the parameters, which includes the height, weight, spacing, curvatures, orientation, the density, the opening or the different kinds of openings, whether it is window, whether it is openings in the facade, whether it is the controlation of the sizes in the design. So this what we had talked about in the earlier thing. Then we have something which is called as the relationships. This is one of the most key element and the one of the most important, because without this we cannot create an algorithm, we cannot create the rules in the parametric architectural softwares. So the elements which are being connected either through the mathematical or either through the geometrical relationships rather than being independently modeled. As I already said, ki, to make each and everything on by my side is very difficult. But let's say I can easily being make with the help of the parametric architecture, with the help of the mathematics, wherein key, for example, if there is a curve wherein the equation of the curves goes like this: 2x plus 4y is equals to 8. So it moves in the same manner and it can create. So see, if you see the sizes, okay, so each and every element, for example, if I'll be talking about any of the elements, either they have been scaled, either they have been rotated, either they have been moved, which is displaced, either they have been moved, or at the same point of time, they have been they have been expanded through their regions. So this is a basic thing what a parametric architecture or how this different sets of design is being created or being curated. Second, we have the relationships. So this is what I talked about, key the mathematical relationships or an algorithmic designs relationship is what we can say that. We have a question, I guess. Please describe the density in design. So density in design or as far as an architectural design is being concerned, density could be in the structural members, whether the panels of the facade, whether the openings, shading devices as far as being in concerned. So for example, if I give an example where let's say if the density is higher, okay, the more shading fins or the smaller openings where the solar radiation is high, we can provide with the same. Where there is at the time of the lower density or at the time of the lower density elements, the fewer elements or the larger openings where more daylight and ventilations are basically been desirable. So it is something key density in parametric architecture. I guess it is very intelligent in terms of the distribution when there is a high density and when there is a lower density uh, spaces being formed. So it can easily be controlled to create a spaces which responds efficiently to environment, and also at the same point of time it can also be efficient in providing the functionality of the space or suffice the functionality of the space rather, I would say, along with the structural and aesthetic requirements. I hope this answers your question, sir. Welcome, sir. So this is what the power of the relationships, or this is very what an essentiality of the relationships in parametric architecture is all about. And along we can also understand in the manner wherein each and every element in an architectural, in a structural, in a civil engineering is being connected or is being in relationship with the other element. For example, the beam is in relationship with the column and the beam is in the relationship with the wall. Of course, I'm not talking about the load bearing walls or the other types of the walls. So this is what the essentiality of relationships in an architecture or in a parametric architecture is important. So again, we would be talking about what an algorithmic design is all about. So again, it is a similar wherein we can create a step-by-step geometrical relationships or a mathematical relationships which are being independently modeled rather than modeling it individually. We can always model it on one go. So this is where the optimization of the parametric architecture is all about. Again, now we come with the optimization. Again, this is one of the most important thing, the optimization, and at the same point of time, where all the architects, all the civil engineers, all the real estate developers are very keen into this optimization, but the people are not using this as on a wide range in Gujarat. That is one thing, but we can also get the multiple design alternatives, and we can also get it automatically in a fraction of minutes. I have created an algorithm. Okay, so algorithm would be consist of the rules. The algorithm would be consist of the parameters. So just by changing the values, just by changing the rules, or just by defining the certain, or by just by adding the rules, I can see a complete new design. So it is something wherein we can get the multiple design alternatives. So, and this is where every architect or every designer is in the need of, wherein client always ask for more and more. So this is where the optimization, wherein a multiple design alternatives can be achieved. And it is always said that ki if I don't know what is more, I can't acknowledge what is the best. So this is what I can do with the help of the parametric architecture. So again, we have associative modeling. And again, for all the structural engineering and structural engineers in the house, civil engineers in the house, all the engineers in the house, whether they are related to the, or whether they are in accordance with the, let's say, the AC segment. AC segment is a segment which stands for the architectural engineering and the construction, or they are from the PDM segments. Again, PDM is basically stands for the product designing and manufacturing. All are in need of this. Wherein, for example, if I'll be talking about this joinery detail which is in the middle. So, for example, if I'll be talking about the header tracks, so the header members and the header tracks are always in the proportion, and also they are in the proportion with the stud to which they have been fixed up. So this is what we can do. For example, if I changed the size or the changed the width of the header tracks, so my the cripple stud would automatically being changed. My header members would automatically being changed. So this is where the, let's say, the magic can happen in our designs, or we can automate the designs, or the automate the, let's say, the functionality of the design based upon the standard operating procedure of our company. So I would urge all the professionals in the house and the students in the house to switch through parametric architecture, because this is something wherein you can automate your drawings rather than now. Before now, what I guess the people who are not using parametric architecture, what they might be doing is something कि अगर header track का size change हो गया है, उसकी width change हो गई, so the cripple stud, the size of the cripple stud also gets changed. So again, they need to turn or the change the entire assembly of the joinery. So rather than doing the same shit again and again, it is advisable, or rather it is to be said that you can use the associative modeling feature of the parametric architecture, wherein you can change the one element and all the other elements gets changed or updated easily. Again, you can see that same thing in the, let's say, the trusses, or the steel structural in the, let's say, the left image and the right image. Yes, sir, it will obviously tell about the moment or the shear connections requirement. But before that, you need to add on, you need to undergo with the certain analysis. So the certain analysis is being prerequisited to identify the moment or the shear connections, whether the structure is in required or not. So see, it is something about that ki automatically nothing will come up. We need to feed the data in, and after feeding the data we can just get the resultant outputs. So the data should be feeded by us, the conditions, whether it is the wind load, dead load, live load, what is the amount of the wind load, what is the amount of the dead load, what is the amount of the live load is being exerted on the structure. And in the reference or in the adherence of the same, it tells us whether the moment of the shear bending is being required or not. So I hope, sir, I have answered the question. Okay. So we have the associative modeling. Second, again, geometric complexity. It can be easily been achieved. Now, this is one of the most important thing wherein the data-driven optimization. So what is you can also see in the same wherein I can where I already answered the question of the sir Goswami sir, whether can I identify the moment or the shear force or the bending moment from the same. So yes, you can very well do that, but you should feed the data in. So it is not just just it can provide me with the help of the structural efficiency, but at the same point of time, for example, if I undergo or if I enter the wind data or the data which has been related to the wind speed, wind velocity, and everything. Okay, so it can say that whether my structural will sustain or it will not sustain. So this is what we can do the data-driven optimizations through the parametric design. And yeah, there would be certain engineers who would be saying that this could be also being easy being done in the Stat Pro or Tekla structural. Yes, it can be easily been done, but as far as Tekla structural or I'm not talking about Tekla structure because it is a parametric software, but if I'm talking about a Stat Pro, so Stat Pro is a structural analysis software wherein it can only say that ki you have a problem and your structural will break. But here, if I say that if my wind speed exceed from this from an X level to a Y level, so there should be a change in my design. So this could be happen or it is possible with the help of the parametric architecture. So now let's come to what a parametric design process should look like. For example, let's say we encounter a problem at our side. Let's say I'm creating, let's go with the same example that I took earlier. That is key. I have created a 57 floor uh, high rise structure wherein the problem or the encounter which I'm facing is something I'm encountering two different problems. The first problem is that key, I'm not getting a proper wind flow in the same, and I'm not getting a proper sunlight. I should get a proper sunlight in my space, and and the building should not affect with the help of the wind flow. Yeah, obviously it would be affecting at a certain extent, but it should not affect to that extent if I create just the standard size. So then this problem has been encountered by us. So first of all, the first design process is you need to encounter the problem. Second is you need to feed in the data. Feeding the data, when I say the data, it would be always been in a relationship with the parameters. So you need to identify the parameters. What are the parameters which are being basically been required? This should be done by the designer's end. For example, I should understand what should be my wind flow, what should be my, let's say, the sunlight or the daylight which has been coming, uh, entering or been invited by the building. So once the data has been feeded, then you need to create a certain set of the rules. Rules in what sense? For example, if my wind speed exceeds from the X to Y, or my daylight, yes, sir, the wind flow cannot be in the one direction in the case of a turbulence. But we can take the reference is just for the understanding, as the wind flow is just an example. It's not something that we would be applying, just we would be applying only based on the just one direction, or on the based of the, let's say, a single parameters, wherein a group of parameters would be acting upon the same. So this is just an example which I'm trying to explain the complete design process of the parametric architecture. So, wherein we would be creating a certain rules. For example, if the wind speed or if the daylight which is being coming from the southern direction should be, let's say, the X amount. So, due to the harsh sun rays, the space inside the interior would be exceeding upon something, and at the same point of time, I need to use the certain mechanical devices or the mechanical appliances to suffice the comfortable temperature in the same. So after creating a certain rules and regulations which would be directly being affected to our design, we would be creating an algorithm. Now, what would be an algorithm would all be all about, wherein we would be including the parameters, and at the same point of time, we would be including the rules. So with the combination of both the things, we would be getting the form generated. So you can easily get the wind flow data and the sunlight data from the government websites of the recurring, let's say, of a particular space. And at the same point of time, you can get the data from the other structures as well. But it is not always the same that I would be getting I would be getting the same amount of the space or the land wherein there would be all the high stories building. For example, let's say if I want to create a building uh, in the Vagodia Road, wherein there are high rises, but they are less in the number. Okay, so at that point of time, I need to um, get it from the government websites, or I need to get it from the, let's say, the surveyors, or the third party people who can get in the exact data of what the wind flow is all about and what the sunlight is all about in that particular region. Second, with the help of the form generation, with the help of all these things, you can create a form generated. You can also generate different sets of the forms, as I've already explained earlier, wherein by just by changing the parameters, just by changing the, let's say, the rules, you can get the different sets of the. So wherein you can easily change in the, let's say, the parameters, wherein you can get the different sets of the forms. And at the same, after completion of that, you undergo an analysis in terms of whether it would be a structural analysis, whether it would be an environmental analysis, whether my wind would be sustained in that particular condition or not. And now there is one software. um, I'll explain the different sets of the softwares later in the session. But there is one software wherein it can say that key, after my building has been constructed, if the exterior temperature is 45, what would be my interior temperature? It can also, let's say, I have inserted an HVAC in my system. So what would be the carbon emission? What would be the saving of the carbon emission if I would be using, let's say, the traditional systems of the cooling devices? So this level of the configuration can be done in the analysis segment. Again, optimization after the analysis by changing the, let's say, the parameters, just by changing the, let's say, the data which we have feed it, we can get the different sets of the output. So this is what the complete process of the parametric design is all about. I hope I made it clear. Second, we will be quickly going about what are the advantages of the parametric and what are the limitations of the parametric architecture. As we are running out of time, I would be taking 15 more minutes, I guess. 15 to 20 more minutes, I guess that is permissible, Vishwa sir.
Yes,
Okay, thank you so much, sir. What are the advantages of the parametric architecture? So it is something key we can explore. We can explore the design alternatives. I can get the different sets of the design. We can get a good control over the complex geometries. We can always automate the design iterations rather than making it individual. It is performance based optimization. It is not just like that. Ki I've constructed a building. It is based upon the data that we have fed it. So again, it has a better integration between the architecture and structure. I have heard that ki architecture and structure always fight like the two political parties in the same room. So this is where the parametric architecture can have a good integration between architecture and structure. Again, it has a good integration with building information modeling and fabrication. Again, it has a very good and a fundamental ability so that it can respond to the environmental conditions. Again, the mass customization of the building components can be done with the help of the parametric architecture. So basically, if I would be making it in very, let's say, if I would be concluding the same, what are the advantages? So it is something key. The parametric architecture helps me in creating or curating the construction in a faster, smarter, and in a flexible manner, along with the optimization of the space, optimization of the constructional data that we can, and optimized structural integration can also be done in the same thing. So I hope parametric architecture is one of the most key important element wherein key it is we can adapt that parametric architecture in our designs if we guys are working with the AEC segment or in any segments. So now what are the limitations of parametric architecture? The one limitation of the parametric architecture is something the softwares requires a numerous amount. The softwares are not cheap. It requires a good knowledge and adequate knowledge of the computational design, not just of the computational design, but also it requires a basic and a good knowledge of the C and Python. In certain cases, if an adequate amount of the data has not been fed, it becomes unnecessarily complex. Again, I said it requires a powerful software and hardware for the large models. Again, it is the construction of the parametric architecture is it may be expensive. A visually complex form does not always mean a good architecture. We have a building in Vadodara itself. I'll not name that building, but there is a building which says that it has been formed with the parametric architecture. So I visited once. I passed through that building wherein I encountered there is no daylight which has been entering in that building due to the complex facade. The daylight has been blocked, and due to which the corridors in the afternoon times are in a required of the artificial lightings. So this is what a bad data feeded can lead through. Second, now this is what our topic was all about. And the main crux of our topic, why sustainability in parametric architecture? What is the need of the sustainability in the parametric architecture? How the sustainability can be easily been achieved or optimized, fully achieved through the parametric architecture. So this is what it is all about. So first of all, we have a limited resources which are available currently. So it is to be said by our, let's say, very learned professionals that sustainability begins at the design stage and it does not begins after the construction. So again, the parametric architecture uses the data-driven parameters to make the informed design decisions. Every design is choiced and optimized for the environmental performance. It is something basically with the help of the parametric architecture, the optimum material is being required. It reduces the construction waste. And how does it reduces the construction waste or optimum material required is just because the parametric architecture is so accurate, wherein there is not a difference of the But again, I would be considering the adequate amount of the data should be feeded inside the scene. Again, it also at the same point of time, it optimizes the structural systems for the maximum efficiency. It lowers the embodied carbon without the compromising the performance. And the one of the key element why we should use the sustainability in the parametric architecture is something wherein the building segment or the real estate segment is one of the largest contributor in the environmental problems. The construction cost the humans around us a 40% of the global energy which has been related to the carbon emissions. Again, they consumes a large amount of electricity, water, raw materials, and at the same point of time, the construction also generates uh, adequate or a massive amount of waste. This means architects have a major role in reducing the environmental impact through the better designs. But to curate or to construct the sustainability or to practice the sustainability in architecture, it requires a lot of time. So with the help of the parametric architecture, we can easily automate the sustainability along with the parametric architecture. Again, climate change is a reality that we all are suffering. The floods that we are getting in Gujarat these days, if we look at the Surat, if we look at the Ahmedabad, uh, if we look at the Valsad regions, so the floods have hit the massive structures, the exceeding in the temperatures, the extreme heat in summers. It is very difficult to go out in the afternoons. So this is what the sustainable practice should is adequate or has been required. It basically helps in reducing the energy consumption, it lowering the greenhouse gas emissions. Again, it can also provide a better quality of life. So sustainability is not just only about just okay, I would be going and I would be protecting a forest, I would be going and I would be uh, planting trees, I would be creating a green building, green facade, but it is also about improving the people's lives. If the physical health of the people is not achieved, then there is no need of the sustainability. Something the way we can also include the better indoor air quality. We can attract or we can invite the natural daylight into our temperatures. We can create a comfortable indoor temperatures which are not too cold, not too hot in the, let's say, the summer or winters, and it lowers the utility bill. if I can enter the, let's say, or if I can invite the, let's say, the sunlight, so there is no need of the artificial lightings, right? If the wind movement across my building is adequate, or if the temperature across my building is comfortable, there is no need of the air conditioning. So, which perhaps is a reason which lowers the utility bill. Again, it has an economic benefits as well. Yeah, so you would be telling that you are contradicting your own thing, wherein you, in the limitation, you said that the parametric architecture is expensive, but here you are saying that it has an economic benefits as well. Yeah, again, it can, the construction of the parametric architecture is high, but at the same point of time, the after cost is less, sorry, which includes with the lower energy bills, it reduces the water consumption, it requires less maintenance as compared to the traditional buildings that we are residing in. And again, the lifespan of a building is again longer as compared to the standard, or the, let's say, the traditional building systems are all about. Again, with the help of all these things, it makes a building sustainable, a smart, and a long-term investment plan. So again, the question arises how parametric architecture supports this sustainability. It is basically, it allows architects to test and optimize the multiple designs options before the construction. So it is to be said that why should I encounter the loss wherein already the technology can predict the same. मतलब जब टेक्नोलॉजी मेरे को बता देगी कि यहाँ पे there is a failure, why should I construct that building? So this is where the parametric architecture allows, wherein you can get the multiple different sets of the design. Again, it helps in the building the best orientation for the sunlight. Again, it helps in optimizing the facade designs to reduce the heat gain. It improves the internal air ventilation. It minimizes the material usage. And again, it can predict the energy performance. Again, I have talked this earlier. So again, the government and organizations around the world, whether it be LEED, whether it be IGBC, whether it be GRIHA, all all the, let's say, the majority of the organizations, or the government certified organizations, or the international organizations are becoming very common, and they are certifying the buildings. So it is to be said that sustainability is no longer an option. It is becoming an industry standard. Before it was being said कि अगर मेरे को achievements चाहिए, मेरे को awards चाहिए, तो ही I would be creating a sustainable building. But now government are being launching these certain standards wherein your building should be a bit a green building, wherein you would be getting a carbon credits, and you have to construct your building within the carbon credits, or within the limits of the carbon credits. So these practices are now being started. Yes, sir, the fire safety is also being taken care in such cases. But again, the adequate data should be entered. So the data in the fire, in the case of the fire, should be such that, for example, if there would be a certain fire-prone zones where there is an electricity, whether there is certain whether certain the paneling is being there in inside of the building. So the surrounding buildings are more likely to have the fire, or to catch the fire in that particular thing. So you can create a certain, let's say design in certain way wherein the fire safety is also being taken care of. So again, the same, the data, whether the data, it's not only just a data wherein there should be numbers, but the data in terms of the, let's say, the or the fire rated walls. They each and every material has their fire ratings. Okay, so you can enter that fire ratings, and on the based upon the fire ratings, you can create the designs in such a manner wherein, for example, in the fire prone zones, you can create, let's say, the You can see that in the fire prone zones or whether there are, and again, for example, it's not just only ki where there are the MCBs are present, or where there are the panelings had been done. But agar let's say fourth floor pe agar mere paas 100 computers hai, to in that particular case also, the fire has been the chances of the fire are higher. So in that particular cases, for example, where there are too many electrical appliances, where the fire uh, where the areas where the fire can easily be flamed off, flamed on. So in that particular case, you can say that key, if that is the case, so the more sprinklers, more amount of the sprinklers should be added, or they or near that there should be certain fire exit doors, or the material should be in such way that the fire rating should be more than 3 or above. So these are the certain rules that we can apply in the parametric architecture, and you can take the fire safety as well in the case of a design as well. So again, I would be quickly been going in the certain case studies, as we are running out of time. We are already 5 minutes. We have 6 minutes we have taken. So we'll be concluding the same just by getting into the two. We'll be getting to know about the case studies of the Al Bahar Towers. This is one of the, let's say, a simple parametric architecture, but one of the very efficient example of a parametric architecture in Abu Dhabi, wherein the design is being made in such a manner which invites the daylight, and at the same point of time which blocks the extreme heat at the same point of time. We all know that ki Abu Dhabi is a region wherein there is an extreme heat as compared to the India. So intense sunlight, glare, and they have created one of the most and the best comfortable indoor environment without using a much, let's say, the artificial, or the, let's say, the mechanical instruments or the devices. They have introduced something which is called as a parametric Mashrabia system. It is again been inspired by the traditional Islamic Mashrabia. Mashrabia is something, I don't know the actual meaning of the Islamic word Mashrabia, but I know what they have applied over here. So Mashrabia in this building is something ki where they have used the shading panels, they have used the computational designs which responds, or let's say which basically changes in addition or in exposure with the sun. So let's say what they have done is that they have identified, or they have taken the, let's say, the average of the solar angles throughout the year, and based upon that the facade of the building gets changed based upon the solar. And this is an efficient building, unlike the building in Vadodara which I talked earlier. So it's not like that, but again, it's one of the best place to visit with. So let's say if somebody who is very keen in understanding the buildings, very keen to see the new buildings, and if they are visiting Abu Dhabi, so this is the one of the best building, but not the best time, to be honest. Uh, Second, we have the adaptive facade performance, wherein it controls the movement of the facade in accordance with the solar shading, which helps in the building's environmental performance. Again, in this particular region, what we can see is that it has an independent shading screen, which I talk about. That is the Mashrabia facade. This is the 2 meter. So which I talked about, the Mashrabia facade, which acts as basically as a secondary curtain wall. So they have already placed the mullions and the curtain walls on the beneath surface, but they have one more, let's say, the curtain wall, which is basically been added upon the same. So it is basically approximately 2 meters, which is approximately 6 feet outside the building. And again, the structural frame is an independent. So this panel are basically progressively adjust in accordance with the movement of the sun. And it is, and you can see that the if I go to the previous, you just see my arrows. I guess you can see my arrows, right? So in this particular case, there is no additional facade in this particular region and in this particular regions, but they have the facades over here. And again, the sizes of the facades at each and every point is not similar. In certain cases, they have certain hollowness. In certain cases, they have just a slight, let's say, very thin, uh, very thin line wherein they can enter the wherein the sunlight can enter through the building. So this is where the role of a designer or a role of a optimized parametric architecture comes into place in accordance with the sustainability. So it reduces the solar gain, and again it reduces if it reduces the solar gain, again at the same point of time it reduces the cooling demand as well. It reduces the solar gain by more than 50%, which again lowers or which reduces the dependency of the mechanical devices inside the building. Again, it helps in improving the daylighting and the views. And again, at the same point of time, you can also get an aesthetic appealing view as well. Let's say if I create a normal box system, though it is very easy to construct, but it does not look like this building belongs to me. The reason why a good architects are getting to are, let's say, are paid in a very high manner is just because they create, they curate, or they articulate the spaces in such a way that it makes the space that it is my space, or it is the space of the customer. So that is where the role of an architect comes into place. Picture. So let's not go more into the structure, but this is where the Opus Dubai is again one of the very good example, wherein it responds to the Dubai's very intense heat, sunlight, and the glare through a controlled glazing and the shaded areas. So this building is such a manner wherein they have a separate amount of the tinted glazed or a different rating of the tinted glaze in a certain areas, and in a certain areas they have a different sets of the tinted area. Again, the digital fabrication has been done, the computational modeling has been done. It integrates the form, which provides the shading from the daylighting, and it helps in the solar control, which helps in the improvement of the building performance. So, with this, we end today's session. I guess thank you so much, sir, NL Goswami, sir, for your remarks, sir. Uh, Thank you so much, Amitabh Kumar, sir, for your appreciation. It is really appreciated to me. If anyone has any question, you can please write in the chat box. Thank you so much, NL Goswami, sir, for attending the talk. It truly means a lot, sir. Again, there is a question from the offline audience, wherein they say that how can AI and a parametric design work together to shape the future of the sustainable architecture? See, I would put the light on what an artificial intelligence is all about. Artificial intelligence is nothing, but it is a model which basically works on the data optimization. And again, the parametric architecture is something which works again on the data optimization. So if somebody says that is parametric architecture being called as an artificial intelligence? Yeah, up to a certain extent, yes, it is true that the parametric architecture can be one of the, let's say, the guiding force as the, let's say, the artificial intelligence. But it is an artificial intelligent in certain, in such a manner wherein you can create your own rules and regulations, unless like the other AI models which are available in the market, which has their own set of the rules, which have their own set of algorithm, or which have their own set of the data which has been feeded upon. So uh, so that's all for today. Over to Vishwa sir. Just a minute. So these are my social media handles. I usually put stuffs which has been related to architectural engineering, and again, what is going around the world, only in the adherence with the architecture. So this is something which I have an interest upon, and I used to post the stuffs on my Instagram. I have created multiple reels on the same. Again, I share the guiding, let's say, the videos or the reels through which we can acknowledge what are the currently industry trends and all. Please do connect, and I would be I would be honored if you get connected on my Instagram handles, on any social media handles. Thank you. Over to Vishwa sir. Finally.
To conclude, a heartfelt thank you to Mr. Nachiket Shah for sharing his valuable knowledge, experience, and vision with us today. Your insight have not only introduced us to the possibilities of parametric architecture and sustainable design, but also encouraged us to think beyond conventional approaches. Thank you to all the students and participants for being a part of enriching session and making it truly so. In this session, there were around 330 online participants and 25 offline participants. Thank you everyone and have a wonderful evening. Thank you.
Thank you so much, each and everyone, for listening me since last. Thank you so much.